Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I'm Roberto, here with us on my
Luciano.
left.
Yeah.
And thank you everybody for following along. If you never did Advent of Code is a code challenge that is published every year in the Christmas period. So now we are looking at the one from this year. You can find them on adventofcode.com. There are 24 challenges. They are not all out yet. Obviously, it's out only until day 11, so today. We are publishing all our code in our GitHub repository. We have a YouTube channel where we publish all the recordings. You can find them in the link in the About section of the Twitch channel. Last time we reviewed the first 3 days in Rust of Advent of Code because we already did them. Today we're going to do day 11. So today we are going to do today for once. Luciano will show us how to solve today Advent of Code basically. And probably first will show us today Advent of Code.
The idea is that Roberto already did it, so he knows exactly what we are talking about, has a solution, I believe, in Python.
Yeah,
maybe not
Python,
in Rust.
like always.
I don't even have an idea of what the today challenge is about, so let's see if I'm going to be like a fool trying to do this while Roberto knows all the answers already.
Today is, I don't want to say easy because if anything goes wrong, it's
going to be even worse.
Yeah, today was not particularly challenging. Let's put it like that.
Okay, actually, before we get into that,
Tommaso is already here. Perfect.
Hello, Tommaso. I actually have a new script that allows me to scaffold a new day. So let's see if that works. So it should create a new folder with all the common structure that we use. It doesn't fetch the input or the README, so I have to fill that manually, but we have a good starting point.
I want that too.
It's an amazing JavaScript file, not Python. Look at this.
Why MJS and not just JS?
A long story, because I'm using this ZX thing from Google, which is kind of it's still JavaScript, but you can do things like this, like $thick, which is like running a bash command if you want.
Mm-hmm.
So because you don't have like a package JSON, you cannot specify that you want to use like top level await or import syntax unless you say MJS.
Okay. Cool. But well, if you have a way to log into... Oh yeah, but they have API. Advent of Code has APIs.
Okay, I'm gonna fetch the input before we even read all of the stuff and copy paste it, and then we'll try to read the instructions. Okay, so let's go back here. So let's see what we do today. Day 11, Cosmic Expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once it's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image, which is our puzzle input. The image includes empty spaces, dots, and galaxies, sharps. For example, this is a representation of the image as text. So this is empty spaces, this is a galaxy, this is more empty spaces, and so on. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there is a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies, like this row sorry, this row, and this column starting here, here, and here. So this row and columns need to be twice as big. The result of cosmic expansion therefore looks like this. Okay, this was doubled.
Yeah.
This one was doubled, and probably the
if you look at
lines here.
the grid is wider by 2 characters. So not 3 characters.
Yeah, because should be
there were
one more
3.
for every arrow there.
Exactly.
Okay. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. So, okay. In these 9 galaxies, there are 36 pairs. If you combine all of this, I imagine
because it's 1 with 2, 1 with 3, 1 with 4, then again 2 with 3, 2 with 4, but it's not again 2 with 1 because you already computed it when you did 1 with 2.
Okay, yeah. So in these 9 galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right. So not diagonal movements.
No.
Exactly 1 dot or 1 sharp at the time. So you can even cross other galaxies.
Yeah, you can cross over other galaxies. He's saying also that later.
The shortest path between 2 galaxies is allowed to pass through another galaxy.
Okay, later was down.
Yeah. For example, it is one of the shortest paths between galaxies 5 and 9. Okay. Why does it do 2 sharps?
Because it goes down.
Oh, yeah, because it cannot go diagonal. So it's doing
can't
1,
go diagonally.
2,
So it's going
3,
right,
4.
down, right, down, right, down, right.
Yeah.
And the last step to go down is counted. Yeah.
Okay, this path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. The 8 location marked sharp plus the step into the galaxy 9 itself. There are some other examples. Okay, in this example, after expanding the universe, the sum of the shortest path between all 36 pairs of galaxies is 374. So what we need to do is expand the universe, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths?
Yeah.
Cool. Sounds challenging enough. I wouldn't say that it's easy. But
okay, sorry.
I don't have Roberto's brain, so let's see what we can do. So where is my ID? Okay, so the first thing that we want to do is probably do a struct. Is this big enough, or should I make it bigger?
No, for me, it's big enough on the phone. So if it's big enough on the phone, I suppose it's big enough on a desktop.
Okay.
Tommaso is saying Manhattan distance in the chat.
Maybe, who knows? So struct galaxy, I'm gonna call it, and inside the galaxy we want to store some information that represents, well, is it galaxy? Let's call it picture or image. What do we call it?
Well, the picture itself, in the end, what I did is that every galaxy is a couple of coordinates X and Y, and the picture itself was a dash set for me.
Yeah, because this way you are not storing every single pixel. You only store, I guess, useful information.
Somebody say to make the font bigger because it's on mobile. I don't know. Which mobile do you have?
Oh, that somebody is our friend Podge. Hello, Podge. Okay, so let's call it picture and we store...
Probably we have to say to Podge that he needs to buy glasses or a bigger phone.
So how do we store coordinates? U sides, or does it need to be I sides because it can go negative?
No, it's up to us. I mean, we parse an image and we expand. We don't go negative if we keep everything positive. So U size is
okay,
good enough.
So let's do this. Let's do fn parse picture. And what we do, we get an input. and the input is a string slice, and we return a picture. So how do we do this? Copilot, let me think for a second for myself. It's already doing it. Okay.
I
Maybe
mean,
should...
yes, is what we did probably in 1000 Advent of Code in Rust
Yeah.
already. We
So yeah,
enumerated the rows, we enumerated the character row in the line, sorry. Yeah, the row.
Mhm.
And then if the character is a sharp, we insert that in the hash set.
Sounds reasonable.
Yes.
So we do that. Okay, so I guess now the tricky bit is that this is going to give us a representation of the
Of the galaxy at
picture
the start.
just with the galaxies. Maybe we can do a quick test just to be sure that this one is giving us what we expect. So if we do, what am I doing? Test fn.
You
test
want to test
parse,
the parser, yes.
just in case, and we do, let's do it here. Const example input str equal this, and I'll need to indent this guy. So what we want to do is let picture stop there. So that should work. It should give us a picture. Let me do a few things. Let me do derive debug. And yeah, why not? And now what we can do...
All the full package, yay.
What we can do is basically... Okay, I'm gonna go with this and then we check the numbers.
Where is taking the numbers from, guys?
I have no idea, but this... Oh yeah, this is the first line. So this is
why those three dots are short?
These ones?
Yeah. Is your font misbehaving or you pasted something strange?
Oh yeah, it's interesting. It's doing some kind of effect. They are still in individual dots, but they are
okay. No, the important stuff is also that there is not a space in front of it.
There isn't.
Okay.
Okay, so 3-0 makes sense. Then 7-1, is this 7? Yes. Then 0-2, that makes sense. Then 5-4, is this 5?
Doesn't seem so to me.
No, that's 0, 1, 2, 3, 4, 5, 6. So this is 6, 4.
Should be 6-4.
0, 1, 2, 3, 4. Okay, so this is 6-4. Copilot, come on. And then 1-5, 1-5. Is that correct?
1-5, yes. 1-5 is okay.
Oh yeah, because we are putting the
0, 1, 5.
Yeah.
Yes, 1-5. That's
then
correct.
we have 9-6.
9-6,
That's
correct.
9, yeah. Then nothing. Then we have 11, 9, 10, 11. And this is what? 8 or 7? 0, 1, 2, 3, 4, 5, 6, 7. So there is 11.
Why 11? Where do you take 11 from?
So 7, 11, sorry.
Now, why 11 again? 0, 1, 2, 3, 4, 5, 6, 7, 8.
Wait, then... Oh, yeah, you're right. Because we're 6, we're skipping 1. Sorry, I was adding 2 to this one.
No.
So this is 7, 8, did we say?
7, 8, yeah.
And then we have 8...
0, 9.
No, 0, 9, yes. And that's it. No, there is another one. There is
also
4, 9.
9.
1, 0, 1, 2, 3, 4. Yes. Okay, cool. So let's see if this works. Wow, why is so slow? What am I doing?
Rust is compiling.
Okay, maybe because I'm streaming.
Okay, passed. So the parser is working. Now we need to expand the universe.
Now we need to expand the universe. So maybe what we can do is implement picture. Maybe I should have called it universe. And what we want to do is fn expand
By a number of steps.
Do we
Let's
mutate or return a new one? Probably it's easier to return a new one.
Yeah, it's easier to return a new picture.
Self. Okay. So we said that if I remember the rules correctly, we need to find columns and rows where there is nothing, and those ones expand twice as much.
Mhm.
But do we have to expand the other ones? No, right?
What do you mean by the other ones?
Like columns or rows where we have universes.
No,
So
only the empty one.
galaxies, I
You
mean.
have to count double the one with no galaxies. So you have first find them.
Okay, I'm gonna use my OCD to rename this and call it universe. And then parse universe. Oops.
You have to rename it.
Okay, so we need to figure out, because now we have an hash map. So
now we have an hash map.
We need to find gaps between rows and columns.
Yeah, now we have an hash map and we can know the maximum x and the minimum. The minimum x and y is 0 and 0 because we started from there. The maximum x and y, we have to find them, and between also minimum and max, we have to look at all the row and columns that have nothing in there. So yeah.
Okay.
There are a couple of ways you can do this.
One way is that we could index the galaxies separately by column and rows. So we can store these points also in another index that is just the column, in another index that is just the rows. So the lookup as we go through the min and max rows and columns is going to be faster, just to see if there is a key there in an hash map, for instance. Does that make sense to you?
Yeah, but if there are two galaxies in the same row, you don't care. You care about to have at least one galaxy.
Right. I guess I didn't want to iterate over all the galaxies, but for now we can do it this way, and if we need to optimize, we can optimize later. Yeah. Because right now we only have an hash set, so we could go through all the values and see, do you have something in this column? Do you have something in this row?
You can extract all the x's as a vector and all the y's as a vector, sort it, and then look for gaps.
Good point. Yes, let's do it this way. So what we can do is so let's do let mute.
You
rows.
can collect. Yes, that. If you do your set .iter.map and you only take x and then you collect a vector
self.0 is there values we don't need to clone, we can do map.
You can't map directly without values on top of an because it's a set. Do you have to take the values?
Oh yeah, you're right, we can just do an iter.
It's not a map, it's a set. Yeah,
and we have here x and y.
Yeah,
and what we want to return is, in this case, for instance, x.
Yes, start with x, and we can collect it into a vector
or an hash set if we want, right?
But if you have to look at the gaps, it's easier if they are.
Oh, because they will be already sorted. You're right.
You can sort that because when he's out of the hash set, you don't know if he's sorted. But then if you look for gaps and is already sorted, you just assert that there is nothing me plus 1 in the next cell.
Makes sense. Okay, what is it doing here? I don't need to put an
Happy.
arrow. Oh, I'm not doing JavaScript. Okay, collect, because this is a reference. So let's the reference. Cool. Then let ys, probably the same thing, right?
Yeah.
And now what we want to do is iterate over all the couples.
You need
So
to
like a
sort
window,
them
a
to
window
have
or
them.
two. Oh yeah, because they are not necessarily sorted.
They are not necessarily sorted. So you can do
can
access
I just do
those.
sort here? Can I? No.
You have to make it mutable and sort in place.
Probably. So xs.sort, ys.sort.
Now you have to
Sounds
filter access to get you all
The
the
max.
columns that the one that are missing. So you have to check them in if I'm 7 and the next cell is 9, we are missing 8. And if I'm 7 and the
Okay.
next cell is 10, we are missing 8 and 9.
Yes, but we need to start from 0, right?
We need
And
to start
convert
from
0
0
with the first cell.
and go back and go to the max. But at this point, we have something in the last cell, probably. And also, if you are not expanding our last column on the right that is empty, is not impacting the distance between galaxies, because no galaxies will be brighter than there. So we can
stop at the last value. Yeah.
You don't have to start from 0. You have to start at the beginning of the vector and then at the end of the vector, because we only care about stuff that are inside our X.
Oh yeah, because at the end of the day,
we
we think in terms of distances. So even if it gets shifted in some
even
direction,
if everything
is
shifted by something on the sides, we don't care. And
Fair
our
enough.
vector already tell us which one is the smallest X and the highest X, because it's sorted. So the smallest one is the first on the left, and the
Copilot
right
knows.
is the biggest.
Copilot knows. Look at the suggestion.
Oh yeah, but I mean, how do you want to do that?
Yeah, I guess I want to go. Let's do let mute missing access, and this is back for now. And what we want to do is for I don't think this is what we want. Let me see. So basically it's going from we want to take the current one and the next one. So it's doing a subtraction and checking if it's bigger than 1. No, it needs to push all of them, not just one.
Yeah, this one is only pushing 1 because he's just thinking of a gap of 1. But if there are 2 galaxies, 2 rows or columns that are 2 columns in this case, because we're going X, 2 columns mixing, it has to push n time, not just
so
1.
What we want to do instead is for
no, I mean the if you can keep the if, because if the next value minus the current value is greater than 1, it means that there is a gap, and there we have to push. How many times we have to push is the difference between these two numbers.
Yeah, I was trying to do that with a range, but let's do it this way first. So for the gap between the two numbers, so whatever, j in the gap which is xs I minus actually I plus 1.
Yeah, minus xs of
I.
1. Yeah, in that minus 1, because
minus 1, yes.
From 0 to that. For j, you don't have to do 0 dot dot that. Okay.
Does it need to be 0? Oh, now you do the plus, basically. You do, yes, okay.
Okay, that.
Yeah, what I
You
was
push.
thinking is if we do a range that goes from this one to this one, then we just push the values in the range. And either the range is empty.
Ah, okay, yes, you can also
But
do
no,
that.
actually, the range will always contain the first value, so it cannot be empty. So that's a stupid idea.
No, you don't have to push the first value because the first value exists.
Okay. So we need to do...
No, but it's fine because if that is greater
If it's an
than
empty
1,
range, it shouldn't do anything. So this is what was my alternative idea.
okay,
Let's see if it makes sense. So what I was thinking is like for j in excess I plus 1, all of this plus 1.
Starting from where?
Sorry, this is the end.
Yeah.
The beginning is excess I plus 1.
Okay.
And
Excluding
then
the
basically
destination.
you just
Okay.
push j.
Ah, okay, yes, makes sense because if they are consecutive, it will not enter in the loop.
What's going on, Copilot?
Something.
Okay.
Oh, okay, it's fine.
So at this point we have all the missing x's.
We have to find the
We need to do the
mixing.
same for the y's, right?
Yeah, yeah. Can you put this in a function that give you the column and rows so we can write a test for it?
A function that gives you the columns and rows, meaning that you pass like xs or ys and gives you all of this?
No, you a function for the universe, like give me empty rows and empty columns from
Oh, I see what you mean. Yes.
function empty spaces. I don't know. Find the emptiness.
Find
emptiness.
empty space. I like it.
The emptiness
And
is
it
inside.
returns what? A tuple of
It returns the two vectors, a vectors of x and a vectors of y's.
back u sides and back u sides. So basically we move all of this. Stop it. All of this here.
So we already have the missing x's. We have to create the missing y's, changing. Yeah.
And this goes from ys and here ys, here ys,
And then you
missing
push in ys.
And then we return a tuple of these guys.
So
Make
already
sense?
here we can write a test because we know with
Mhm.
our input that we have 2 rows and 3 columns that have empty spaces, and we can see if we're getting them right.
Yeah, great idea. Test-driven development for the win. Test find empty space. Okay, example input. Oh wow, is this really the value?
No, I don't think so because we have 5. If you look at the README on.
Oh yeah, the README tells us. So let's go
Yeah,
there.
in the README show you which are, and those are 5 in total, and I think.
Okay, so we have column 0, 1, 2, 3, 4, 5. So 2, 5, 6, 7, 8.
258. Okay.
258 should be here in the first one.
Yeah.
2,
Copilot
5,
is just drunk.
8. And then the other 2 are 0, 1, 2, 3, 4, 5, 6, 7. So 3 and 7. 3 and 7.
Okay, let's see.
Let's run. Okay,
we have found the right spaces. Okay.
So
Now
Thomas is giving us a suggestion saying we can use vec with capacity. That could be a nice optimization.
Yeah, but you don't need to know the capacity to use vector capacity.
But I guess the maximum. Oh no, yeah, we don't know the gaps, right?
We know the gaps of the README, but we don't know the gaps of your input.
Yeah, I guess you could assume by doing the difference between the min and the max that that's the maximum. But
Oh, yeah,
I
you can.
suspect that in the next part of the game, if we keep expanding the universe, that might allocate lots of memory for no reason, right?
Yeah, I mean, let's keep it like that for now. If we over allocate, we can optimize later. Let's make
Mm.
something that works first.
Okay, so the next step is to expand.
In the test, your galaxy is still called picture, by the way. I don't know if you're fine with that.
No, I'm not. Thank you for fixing my OCD.
No, this is the universe,
Universe.
sorry, not the galaxy. Anyway, it's not a picture anymore.
And here still call him picture.
Same.
What the hell?
Copilot read your tests and wrote just the same
Exactly.
stuff you wrote.
Copilot learns from my stupidity. Okay, so here let me do a favor to Clippy. Okay, so expand. So the idea of expand is basically what we could do is for every gap, we need to push everything after the gap by an
Every
additional point.
galaxy writer to the gap needs to be moved by one
One
coordinate
for every single gap after.
for every single gap. Yes.
Okay, and we can independently move X and Y, so it shouldn't be a big
Yeah.
deal to do one or the other in whatever order.
Yeah, exactly.
Cool. So we need to do something similar here, where what we can do is use the function.
Yeah, you
So
have to call the
let's
function to get the
missing
gaps.
X and missing Y's, exactly that. Then what we want to do, let's do a new galaxy. Let mute universe equal self clone.
But we don't
And
start with an empty one. Why you want to close? Because you want to mutate.
is it easier to start with an empty one?
So it's not easier to take a galaxy from the old universe, move it to the new universe in the right place.
Could be.
But well, up to you.
Okay, so yes, let's do it that way. The problem is that I guess you'll need to know how many shifts you are doing for every point, right?
But you know.
So either we iterate by the galaxies or we iterate by missing X and missing Y. Probably easier by galaxy than if we want to place them into a new hash set, right?
Okay, so we want to start with a new galaxy
Okay,
and
so
iterate
let
over
new
new
universe.
universe, and then iterate on top of the.
For now, I'm just going to do a bare hash set new. And then we iterate on the existing ones. So let galaxy, for galaxy in self.0.iter. What we want to do is basically saying Copilot, calm down.
No, Copilot is completely wrong here.
I like the first line, then I don't like anything else.
Yeah, exactly. Thank you for the. But you
So
can do the first line also in the 4 if you like.
yeah, we basically need to count how many gaps we fall into on the X and the Y, and then use this delta to calculate the new coordinates, right?
So you said we have to count how many gaps do we have on the left for the X and how many gaps we have above us for the Y.
So let's do let num gaps left, which is basically, oh yeah, is that good enough? I think so. So we iterate over all the missing X. We filter by the x's, these are the missing x. So let's say missing x. And we basically said that the current x needs to be bigger than missing x.
Yeah, Copilot wrote x and x. Yeah, Copilot was again wrong.
Copilot today is tired.
Okay.
And
So
then we need to do
now
the
we have
same
to do
for
the one
gaps above, yeah, because y increases.
going
Okay,
down.
so now we have missing y
Yes.
and y. So here is missing y needs to be smaller than y.
Okay.
At this point, we have let new galaxy, I
At this
guess.
point, we have to push to add to new universe.
We need to say that the coordinate of the galaxy is the old x plus
Plus the gaps, not mean.
num gaps left and y plus num gaps above. Okay, now we can push. And if this is not mutable, it's not going to let us push. And then at the end, what we want to return is universe, new universe. Make sense?
Yes. So you want to do a first round of expansion and write a test for it?
So we can do the example one.
Yeah,
So
on top of the example.
fn test expand. Or let's call it, this is going to be part one example, right?
Yeah, this is the example, yes.
Actually, let's do it this way. Let's do part one because at this point should be relatively easy. So we parse the universe. Don't do this. Just do it once.
No, we expand once.
We expand once. And now what we want to know is, oh no, we need to do all the distance stuff. So this
We
is
have to do the combination between all the points that we have in the galaxy and compute the distance.
So
between
there
all
is still
of them.
work
And
to do
Tommaso
there.
before was saying Manhattan distance, and yeah, then you return it.
Okay, so that's for later. Part one example. So for now, what we want to do is test expand, fn test expand. So we do let universe expand. Now, does that make sense?
I can tell you the numbers of the expanded universe of the README if you want.
Oh, we can copy paste this, right? And parse it
No,
again.
I already have the number. If you want, I can tell you the numbers that you have to put in the test.
I trust you. Go for it.
9, but you can, well, you were able to keep the structure. 9, 10, 4, 0, 12, 7, 5, 11, 0, 2, 1, 6,
1,
9, 1,
sorry,
1,
1,
6,
6,
9, 1,
9, 1,
8, 5,
8, 5,
0, 11. And please,
0.
Copilot, stop trying to guess numbers. You are not getting them.
So can we just test?
Yeah, if it's doing the same as the Python one.
Ooh, worked. Nice.
Yay. So that is the expanded. Now you have to do the combination between all the points, compute the distance, and sum all of them together.
So we can probably do that as another method.
Do you have something in Rust to do combinations? I mean, in Python, in iterators, you have combinations.
Probably you can use the iterators from Rust, but it's a library. So let me think if we can do it. Let's try now. 1 second. What the hell? Can you just let me do this here? Fn, what do we call it? Points?
The combination.
Pairs? Combinations.
I mean, it's a combination with two elements.
Combined. I don't know.
Pairs, galaxy pairs.
which should return something that implements an iterator of
a galaxy is a usize, comma usize. We need 2 of those.
Yep.
Zip. Tommaso say zip. I lost the context.
Zip is gonna. Is it gonna work? Zip? No, because it's only gonna allow you to combine with the next one, not with all
Now
the
you have
other
to do
ones.
that with all of them. So is 1 with all the other ones. Then 2 with all the other ones except 1. 3 with all the other ones except 1 and 2.
Basically, in a for loop, you could do 2 nested for loops where the
Yeah,
inner
but
for
in the
loop
second
starts
one,
from the current index, right?
yeah, but it's an hash set, the galaxies for us. So can you start in a hash set iterator at a certain index?
Well, you can allocate all the values in a vec and then use that.
Oh, yeah, with a
iterate.
vec, yes, you can. I was thinking without copying everything in a vector that we could do.
Because there aren't many galaxies, right?
No,
I
mean,
imagine.
even in the final input, they are not
Let's
a huge
check.
number.
Let's check how many.
Count how many sharps.
439.
I mean, if you allocate that number of sizes twice, it's not going to kill you. Okay, let's collect the hash set into a vector and do the double.
Yeah, I
for
don't know
loop.
if we can do this as an iterator. Let's see. So let galaxies.
Why we can't do that as an iterator?
Well, not easily, because let's see what happens.
Let's see. Okay.
So vec of usides.
Tommaso was saying that in an hash set you can call iter and then you can call skip, so you can skip the first elements, hoping that the hash set iter is always giving you the stuff in the same order. I would say that it's safer to go with a vector.
Yeah, let's go with a vec and then we can test it at the end if it doesn't break our tests. So self.0.iter.clone.collect. Yeah, that's what we want.
Why we're cloning again? Because otherwise we get references.
Which honestly shouldn't be a big deal. Right?
Yeah, because also cloning is not a big deal because they are usize. So
I guess. Oh yeah, it implements copy, so it's copying anyway.
Okay, perfect. So the clone was not useful.
Okay, so now what we want to do is, oh, look at that. So we can probably use iter. So it's doing galaxies, iterating over them. Enumerating, I don't think we need to do that.
To get the index to start with in the inner loop, we need it.
Oh yes, and then the flat map is what we want to basically be able to combine an inner iterator and an external iterator as if it was one list.
Okay, let's try this without making the vector at this point.
So basically we can remove the to do. And let me review this code because I don't trust Copilot.
Yeah, but we don't need... well, let's leave the vector for now.
This is item equal. And now collect is not happy because then it wants this probably. Does it? Or wants a reference to the table, I think. And now this doesn't work anymore because it's going to be something like this, which is not a big deal. Is it?
Now he's complaining about...
We're building something else. Oh, because here I was the referencing. Okay, what's the problem now?
It's a double reference. Put a star in front of the open brackets in line 57, yeah? If you the reference there with a star, can you do that? No.
Okay, should we clone like
lost.
crazy?
I got
Let's clone
lost.
like crazy for now.
Let's clone all the stuff. And remove the reference on the left in the declaration then.
Reference there, yes. And now why you are still not happy? Because there are
Let's
still
map,
references.
do an into iter at the end of all of that.
If you do clone here, I think it's gonna be happy. Is it? No.
No, I think you have to do an into iter at the end of all of that, line 58.
But if we do that, then we consume the galaxies. Oh, well, but well, we can consume because it's.
You can consume is our copy.
But then you cannot redo into either here. I think that's the problem.
If you do
Because
into
it's
iter in line 58 before returning.
58. No, you
58.
need to do it either here or here.
No, at the end of everything. 58 after the closed round bracket. Can't you do into iter there?
But I don't think. I think that just doesn't create an extra reference. Is that good enough? Nope. Okay, let's do this thing. Because this shouldn't be a big problem, to be honest, to receive this, right?
To give back that. But now he's complaining about
Galaxies is borrowed here. What? Borrow of galaxies, returning this. Ah, okay. Where do we clone?
there. You have to clone there.
Galaxy 1, Galaxy 2. Okay, clone. Still, what's going wrong?
Still, complaining don't live long enough.
Galaxies.
But we are cloning. Let's do with two nested for with numeric indexes and
Also, do we need to do a move?
Oh, yes, I was about to ask about it. There is also a move in line 57.
To force the cluster to take ownership of Galaxy, use the move keyword.
Because we use galaxies also inside the second iterator.
Yeah, but is that a problem?
Because we are using that also outside of the in line 53.
But can it just take a reference?
Now flat map is not happy. Why is not happy?
Okay, I have even the VS Code is going crazy. The trait iterator is not implemented for okay, here we need to return iter. What do we return? Because we need to wait. Let me reread this. So flat map doesn't implement iterator.
The move in line 57, we need it.
Also good point.
Okay, nothing changed.
It's saying that iterator is not implemented for map of skip of slice.
Because we are using a skip, is that the problem? Our skip in line 56?
I don't think so. I mean, if we assign all of this, right? Let's say let inner iter equal that. And then we return inner iter. we can see the type here. And the type is a map of a skip of iter, blah, blah, blah. And it said that this one...
You need to collect that?
No, because if you collect, you lost the... Like you are materializing everything. You are not producing. Okay. We could clone and collect, right? That's a solution. We are trying to do a dynamic iterator.
Nested iterators. So flat map, what should return?
Flat map returns this guy. A map of this one. Is it?
It's completely designing the wrong type because it wants to return an iterator. It wants the return type of the closure inside to be an iterator, but we are not returning an iterator. We are returning a map skip iter that is not an iterator.
Which should implement an iterator.
It tells that is not. The trait is not implemented. Map skip iter.
Okay,
the trait
but
iterator
if
is
we
not
do...
implemented.
If we do inner iter dot iter. Oh, it only implements into iter. Why is that?
And if you do into iter, what is happening? You are cloning and materializing.
I have no idea.
So comment out that line. So now he's happy about the types, but he's complaining about cannot move this out of the reference because it doesn't implement the copy trait. So now you need the move that was there before.
Can you do cloned? Or
it's not cloned. I'm not cloned.
Okay. Galaxies does not live long enough.
Why? Who is killing it? What are we returning? We're returning an iterator on top of galaxies. Yeah, when we exit from this function, galaxies is deallocated, but the iterator still wants to use it.
Okay, exercise for the reader.
So we return a vector of tuples. Nice.
And we say let combined galaxies equal this is a vec of
do vec underline and then create a new one. The first time we put something inside it will infer the type.
If we want to use collect, I don't think so.
Because you want to use collect. Okay. I was just looping 2 times and pushing stuff into it.
Yeah, I guess one thing we could do is do this. Do type galaxy equal this.
Now an
then
alias.
Basically, from here we do. Well, I also. Okay. Now this is a vec of galaxy. So couple of galaxies. Now this is a vec of galaxy, then a vec of combined galaxies. Okay, so now what we want to do, either enumerate flat map. Cool. Then here at the end we have to collect.
Put, semicolon, and we have to return combined galaxies. At this point, is this correct or is complaining somewhere?
I forgot an angular bracket. Okay, do we need to do all this crap now? Probably not.
Okay, we have to do an into iter because otherwise flat map is complaining about the type.
Into iter where?
In line 64, you removed the into iter and now the flat map type is complaining.
cannot move inner iter, which is behind the share reference.
Hello, K Bono in the chat. Witchcraft. Yeah, we are trying to make witchcraft, but it's not going very well.
Yeah, absolutely. Yeah.
You're still on day 9. Oh yeah, but day 10 is
Was a
no,
pain.
Day 10 was not easy.
Was a pain for me, day 10.
Yeah, there was only a lot to write, but
okay.
I was able to make nice visualizations, so I was happy.
So it's basically suggesting again to use clone.
Okay, now what is complaining?
Now what's the problem? Using clone on type USI, which implements copy. Okay, thank you. You could have said that before. What else? Collect.
Now
Why
the collect
you're
is
not
complaining
happy? A value of type
because there are references to galaxies.
Cannot be built from an iterator over elements of. They are still references, right? So we need to do here into iter again. Can we do that?
You're suggesting it, so no, because into iter is ungain references. So we have to map the references.
Damn. So what are we getting?
Galaxy
A.
1 and Galaxy 2. Yeah. We get A, comma B, and then we have to do star. And then we have to return a tuple with star A and star B. Is this enough? Or will we start to bother us?
Almost. Now what's the problem there? Closure may not leave the current function.
So now we need the move? No. We need to map move or not?
Closure must leave the current function. Let's see here. What's the suggestion?
To add move.
In line 62. 62. So to add a move here. Jesus.
And
okay. And now what is the problem? Useless conversion of the same type. So now we can just return into either.
No, because it's complaining.
Consider moving into either, just clone. Oh my god, we did it.
And now, okay, we did something. Tommaso was saying flat map cloned collected. Flat map cloned. Instead of map, doing cloned and removing the map. Still happy?
No, doesn't seem happy, if I understood the suggestion.
Yeah, what is complaining? That is still references instead of values. Okay, let's go back to the map.
Yeah, I think cloned doesn't go inside the items of a tuple.
Because it's not cloning. We don't need to clone inside.
I think if it was a reference here, then cloned would work.
Yeah, exactly.
Okay.
Anyway, we have the Galaxy combined. Yay!
Jesus. Okay,
now,
so
part
test.
one, what do you want to do?
Do we test the combined ones?
It needs to give us 36 pairs from what they say. Do you want to assert on top of the length of that? Tommaso said that we were right.
Yeah.
Once in a lifetime it happens.
Test.
Even a broken clock is right 2 times per day.
So give me the example. Yeah, there. It doesn't matter if we expand or not. If we
no, because the number of galaxies is not changing. It's just changing the coordinates of them. But now we are asserting on top of
combined galaxies equal universe.
Tommaso says that we could have returned a vector of references to galaxies or something. An iterator item galaxy plus lifetime anonymous.
Okay, so what we were saying is part one, what we can do, we expanded the universe, now we get all the combined galaxies, and now what we need to do is to calculate the distances between all the galaxies, and then we need to sum those distances. Is that it?
Yes, we have to sum the distances.
Okay. So what we can do here is basically dot iter and dot map, and here we have galaxy A, galaxy B, and how do we calculate the distance?
Tommaso was suggesting the Manhattan distance.
Which is this one?
No, that is the real distance. No,
Because
Manhattan distance is the absolute of the difference in x plus the absolute of the differences in y.
Because in reality, what we want to do is not the distance itself, but do the path.
Yes,
right?
because you can only go left and right. So if you go all right and all down, is the same except of doing that stuff. So
okay, so the Manhattan distance makes sense. Thank you. Sorry, I'm slow to understand the stuff. So let's say another thing. Let's say XA and YA and XB and YB. So basically what we want to do is...
not this one.
But close enough. We just need to remove the power, right?
We need to return x diff plus y diff, no square root.
And no power.
And no powers, yes. And y float, no idea, return
because it was doing a square root, and I think square root requires a float.
Why are we casting two I sides?
Because it's doing a difference, so it could go...
Yeah, it could go negative. Why the abs is an I size again? So abs is not giving you an absolute.
Interesting.
Well, who cares? No, but don't cast. Let's cast only once at the
end.
Yeah,
we can cast the distance at the end. And we don't need the parentheses.
No.
Okay, so at this point we are mapping and returning the distance. Now we need to sum.
Yes.
Right?
If you run this for the readme input, it say that the sum is 374. If you want to test it,
374. 7, not 6. Ooh, what did I do?
There is
wrong
a typo
syntax somewhere.
You put the pipes.
You forgot
to close the pipe.
Okay, so what is the problem? Oh, come on.
Okay, references, cloning.
Okay, so ready to test. 3, 2, 1. Go! Okay. Green. Nice. Okay, so now we can run this guy and make it fail because I'm just saying 0, and we will see if we get a value that Advent of Code is happy with. Where is my Advent of Code? Nice, that's the right answer.
Okay, update
so,
the test.
Part 2. Oh yeah, let's update the test. Good one. Now, let's go to part 2. The galaxies are much older and thus much further apart than the researchers initially estimated. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. Okay, that is each empty row should be replaced with 1 million empty rows, and each empty column should be replaced with 1 million empty columns. In the example above, blah, blah, blah. Okay, we have some example numbers we can use for example. So the only difference, if I understand correct, is that we need to do the thing 1 million times more, which will probably be slow, right? Or
now look, read carefully.
Okay.
Each empty row should be replaced. Before, each empty row was replaced with 2 empty rows. Now, every empty row should be replaced with 1 million.
Okay. Makes sense. So we can probably change our function and have a parameter, something like expansion
Exactly.
rate.
We can change the expand rate was 2, not 1. Watch out. Before was 2, and now is 1 million.
And that's it. That this is just the example.
Then
right?
in the README, it tells also the README example expanded 10 with the power of 10 becomes 1030. Expanded by 100, it become 8,410. When I did mines, I tried those two with test just to be sure that I was getting it.
Okay, so let's do that. So in the expand, what we want to do is expansion rate, which is a usides, I imagine.
And for part 1 is 2.
Where do we use it? We use it in where is it? Where do we add the value? Oh, there. No gaps left. So this needs to be +2 plus the expansion rate.
Not plus. Multiplied.
This one alone.
Yes, that one alone. Yes. You don't need brackets if
You're
it's a
right.
multiplication.
Multiplied.
Now,
multiply the rate -1.
Okay, yeah, exactly.
Okay.
The rate -1.
So
now
there,
you need
we need parentheses.
Yeah. I was about to tell you, watch out, you have to do them in -1 because
And
like
the
we said
same,
before.
The same
And
here.
the same for and
Okay,
for part 1,
now
if everything
this is
works,
complaining. Expand 2.
And in theory the test should still be green.
If we update the test as well, expand 2. Let's see. Still green. Cool.
And also the test for part 1 should still be green. What is it?
This guy.
Yeah, that one and the one below.
And the one below. This one.
Line 190. No, 190 there. Okay.
All right. And now what we can do is part 2 is pretty much the same.
Yeah.
Except the rate is different. So let's do fn solve input str expansion rate usides, and it returns usides, and it copies all of this where expand is expansion rate, and this basically returns solve input 2. Copilot, calm down. And this one is solve input 1 million.
Can you fit? Okay, your size is big enough for 1 million. Because it will be 1 million multiplied.
So.
Otherwise, you have to switch to U128 probably. But well, let's see if it's enough.
No, I think because this is generally U64. Maybe we need to be explicit and make everything a U64.
Okay, let's see if it's big enough.
If we want to be compatible.
I remember that when we worked on the Raspberry Pico, we had the problem with U64 being a U32, so being too small.
Okay, so we just go with part 2 or we do the test?
Yeah. You can write the README test for this because we know that after 10,
let's do that.
We have what number after 10 with a power of 10? We should have 1030.
Test part 2 example. So what we do is
but it's not exactly part 2 because it doesn't tell you part 2 for the example. It tells you after 100 or after 10.
Yeah, let's do a solve of 100. So let's just call solve example input 100.
Okay,
And
with
what's the
100,
value?
it should be 8,410, 84110.
Let's see if that's true first. Good.
Okay, it's going well.
And then the other one was 1000?
10 times, and it is 1030, 1030. But I mean, if 100 is correct, I don't see why the other one should not be.
Okay, just in case. And now if we run this one, it's going to fail, and hopefully we get a number that we can use there.
In Advent of Code.
Fingers crossed.
I mean, the ring is working. Okay,
so look at this. Look how many stars. Okay, cool. How do we use...
Update the test in Rust.
Oh, yes, good point. I
Because
always
it's
forget.
0 and 0 is wrong.
I always forget.
Okay, now if you run the full suite of tests, everything should be green and no complaining about unused variables or... Nice.
Cool. 8 tests. Okay,
We
can we try to optimize anything?
What can we try to optimize?
Let's do a cargo bench first.
Okay, because you already have all the scaffolding, right?
So 11, we do cargo bench, and let's see if we can improve performance a little bit.
I think the speed of the two parts should be the same because it's just a multiplication. The difference is... No, it's not even because you multiply also for part 1. It's just that you multiply by a smaller factor.
Yeah, they should be very comparable in terms of timing.
Yeah. We created a vector instead of doing iterators. We could try there to make to return references instead of cloning like crazy. Yeah, because 700 microseconds is slow for Rust. No, it's not slow for Rust. Almost a millisecond. Oh my god.
Okay, let's see if doing less cloning gives us slightly better timing.
Yeah, let's see if we can do less cloning, because that iter inside an iter with the move is black magic for me. Like somebody before was saying, witchcraft, yes.
So what Tommaso was saying is iterator of item equal...
Then references to two galaxies.
Is a reference here or reference
No,
of
without
galaxy?
a reference there. Is a tuple of references.
Because we get the references and then we combine the references. And then the idea was that there was a plus tick underscore.
Yeah, that what it means.
Sorry, that needs to go inside. No, where does it go?
I never know where to put them. Okay, without that one, what is happening? What is complaining about? Point 1, we don't give an iterator back. That's probably the first problem.
Oh, it's saying din. Oh, yeah. Well. Or I need to use implement, which I was forgetting to say. And now can we do that? Plus tick underscore. Okay. Yeah, we're not returning this. Fair enough. So if I do a to-do, are you going to be happy with it? With the whole syntax or not? Rust Analyzer just exploded. Because to-do returns an empty thing. Okay, so to-do doesn't work in this case.
Okay, Rust Analyzer is exploding multiple times.
How do we do...
Dean? Tommaso is here again.
Okay, let me do one thing first. Let me
commit. Or was here all the time, I don't know.
Let me commit galaxy. So...
okay, yes. You have to remove the semicolon in line 72.
Let's commit all of this first.
Yes, you're right. Run a test before committing just to be super sure.
Yeah.
Okay. The mouse is saying try in dim and try to remove the map collect.
Why din and not impl? Because generally when I do the iterator thing, I use impl, iterator something. Right, that one.
You are forgetting the references before the galaxies.
Good point.
And try to remove the map and collect in line 69 and 70. Tommaso was saying
So
that.
all of that.
Also the map.
And also the map.
And now you return galaxy combine galaxies, or you remove the let.
Now we remove the let. Well, let's do this. We remove the annotation as well. Combine galaxy, so we can see what is the type there. Okay, it's saying implement iterator. What?
So is happy? No, it's not
It's
happy.
not happy, but interesting enough.
What is the error? Sorry.
Can return a value referencing a local variable galaxies. Because galaxies was a clone. So this is not going to exist once this function return. So we cannot.
We are using the skip, so probably we can work directly on top of the self zero. So instead of doing
yeah. So if we use self zero iter.
No, just self zero, because you're already calling iter on top of galaxies. So replace galaxies with self zero also in line 5. Okay, everything is moving.
Oh, is that green?
What's happening here?
It seems happy.
So let's review what we did. We said self zero iter enumerate flat map. Thank you for being so there. I size, I and galaxy. Okay. Then on top of this, inside we do another self zero. What is self now? There is not zero.
Here,
we don't.
here.
Ah,
zero is on the other line. Yeah, I don't know why Rust formatter likes this.
No, yeah, but I lost self in the between annotations and what we wrote. Sorry. Iter skip, then map the galaxy 2 because we need galaxy 1 inside, so we move it.
Mm-hmm.
Then we iterator clone. We still need this.
I don't know.
Hello Rex 085.
Hey, hello. How are you?
Okay, is happy. Tests are still green at this point.
Tests, let's run them. So let's do it here. Cargo test. No, it wasn't up. It just crashed probably.
Because the combined we have to do iter count now instead of len.
Okay, it's breaking in the usage. Fair enough.
Yes, because we before was a vector, now is an iterator. We have to use it differently. For example, we don't iter on top of an iterator.
Just this.
Yes, it's already everything we need. And in the tests, the len is not the demo, so we have
account.
to do is account.
So that's in which line was it? 180. 180. Okay, so here we can do dot iter.
No, it's already an iter. We just have to count.
Just dot count. Yeah.
In theory. Okay, somewhere else we need to change.
All green, amazing. Now cargo bench again.
Okay, is remembering the previous speed that was 700 microseconds, but let's see if he's faster. Sbam! Like Tommaso says. Now, Tommaso, explain us what the fuck is quote underline. Okay, 50% faster.
It's good.
And the second one, no, that
also,
okay, 50% faster.
That was a good improvement.
We are cloning way less. Nice.
Okay. Anything else we wanted to improve? I remember there was some other suggestion, but not what was it?
where we cloning, where look at the clone that we do.
So we clone here, but
There is no way of probably there's no way of avoiding that.
and this is a clone of an iterator, so I think it should be relatively cheap because it's just gonna keep track
Yeah.
of the current element.
There are
Not
another
not
couple
clone
of,
all the items. Basically, should just clone the pointer of the iterator.
Mhm.
Other clones. There are other three. Well, this is
Well, those
clone
are
in
in
the
the test.
test. The other one is in the test, and the other
Instead of
one is the.
instead of iter clone, you can do into iter when there is that in the test when you have the array.iter.clone. Can you do into iter and collect?
Actually, probably.
Tommaso is saying the quote underline is required because the first iter capture self 0, so the iter should remember self. The quote underline is a typical trick to let Rust know that. Because the iterator is working only if self is still existing. Otherwise, obviously can't
Yeah, I
reference
guess
galaxies
otherwise you
itself.
need to do some crazy generic stuff and start to put like a everywhere.
In all the references, yeah, okay.
Yeah. Like
I think that is less code. Once you know what it does, is better. Cool. I think. Do we want to close here for today?
I think I'm happy. I can do a commit after the stream, but yeah, we can do the
Okay, so
closing.
let's wrap it up. You can find the recording on YouTube. The link is in Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday at 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave comment, open pull requests. The repository of the code is still the one from before. Luciano posted it in the chat anyway. Everything is well accepted. We are trying to learn Rust, so don't expect our solution. We throw exceptions, but you have to expect our solution to be the cleanest one or the more idiomatic ones. If you know better ways, let us know. Thank you to Tommaso for all the suggestions and everybody in the chat. Yeah, Tommaso was saying the vector with capacity, but now we removed the vector. So, no, it was vector with capacity for the collection of missing X and missing Y. Remember?
I will say we'll leave it for next time or for an
Yeah.
offline PR.
Yes, I think we are fine. Thank you, everybody. Are we going to raid somebody?
Yes. So see you next time.
Bye.